Hello, everyone, and this is a follow-up episode of the last one for Aiken, where we did the basic setup and started on the Hello World. It has been a very long time since I did the Pluto's Pioneer. I think it's almost 2 years now. I had honestly forgotten most of it, so it's really good to do a refresh of this. And I think today we will have a simple episode, just revisiting the Hello World and trying to look at what is really a redeemer, what is the validator, what is the datum, and all of that. Because if you remember in the first one, we did the full environment, we set up the VS code, and we have now integration with Aiken on it, so it identifies the Aiken code. We had a validator script, we had a locking script and an unlocking script. And yeah, let's start with the redeemer. Or actually, let's start with all of it together. Let's see here. So actually, this is the good one to start with. So this is one of the videos that's recommended on this, and in a regular UTXO you have a pubkey and a signature, and with the EUTXO you can also have a script doing some of this, and you can actually
attach some kind of key to the output that says this is the key this is the public key of the person who owns this, and then in order to spend that you have to actually sign your transaction with the private key, and then we can say yes, this transaction could only be created by someone who controlled the key.
That's the standard way. You have a transaction, you have a pubkey, you have a signature for it. That's the way you can make the transaction.
Before they have the right to spend the money. And this is often generalized a bit to a model that includes scripts, some more powerful programming language. And so instead of just having a public key, we actually have a program, which we call the validator. And instead of just having a signature, we have some kind of input, which we call the redeemer. And the validator is given the redeemer as an argument, and it says yes or no. And that's how you decide whether you're allowed to spend the output. And this is actually how Bitcoin works in practice.
Usually, a redeemer redeems something from a validator with a datum. We will see that.
Bitcoin has a script language, and even simple public key locked outputs are implemented with scripts. The script just says, is this a valid signature for the corresponding public key? But it is nonetheless a script. They're all implemented that way. We extend that even further.
Yeah.
So we add two more things. The first thing we do is we add a bit of data to the output. We call this a datum. Datum is the singular of data, which nobody ever uses, but mostly it's a word that sounds like data, but isn't data because data is extremely overused for just about everything. So this is a jargon term for the bit of data that goes on an output. And this is quite handy because it's a nice way to attach extra information to outputs without modifying the validator, because the validator typically determines the address of the output. So ideally, you don't want to mess with that. This is very useful for carrying state, for example. The other thing is that the validator gets to see this vaguely named context. And this is the context in which validation is occurring. And so what this usually is the entire transaction that's being validated.
Yeah, on Cardano, we have the whole input and output set for that transaction. On Ethereum, for example, we have a more global set, so not only that transaction.
So what this means in practice is the validator can see the entire content of that transaction, which means it can see how you're going to spend the money. So if you just give someone a redeemer that's the signature, you say, well, here's the signature, check the signature is fine. You have no idea, and then you can do whatever you want with the money in the rest of the transaction. The validator can't tell. But we actually let the validator look at that So it can see the other inputs, it can see the outputs, and in particular, this lets you do interesting things like assert that there is an output locked by the very same validator, which has some of the money in it or something. And this lets you create chains of transactions with the same validator, which is key for doing more advanced patterns like state machines.
Okay, that's more advanced. But yeah, let's also see it here. Yeah, they explain the same in the simple UTX model. There's public keys. You can consume that as an input for another output. And the EUTX model extend this by adding scripting address that can run arbitrary logic validators. And instead of just having like signatures for transactions, so you have the pub key and the signature, that's the regular UTXO, then we have the redeemers. These are arbitrary pieces of data. And we have an additional arbitrary piece of data called the datum, the singular form of data. And you can think of it as a little piece of state that sits on the UTXO. And as he said here, like there's a context, and the validator can know this context. And in Bitcoin, you just know the redeemer. It's very global in Ethereum. In Cardano, you get all of the inputs and outputs from the transactions being validated. So in that UTXO address, the datum resides when you do a script with an output. And then the redeemer coming from the input and the validation and the context consists of the transaction being validated and its inputs and outputs. So it's a combination of all of these things. Let's try to look it in the actual code here. So, or we can also even look it here. So here we're creating the validator. It also creates the datum and the redeemer type. So what data type? And here is actual validator. It says a function. It accepts a datum and a redeemer and a context, which is a script context, as we just saw. And you have a need for both the must say hello and the must be signed data. And then you have the locking. And it uses the BlockFrost library for the API. It uses Lucid for the transaction signing. So you also sign, of course, with transactions. And we're using TypeScript with Dino. And here it's checking the BlockFrost API using the BlockFrost API key in the preview testnet, getting the private key from using TypeScript with Dano and with Lucid. I guess Lucid uses TypeScript. And then it's calling the validator, I think. It's returning a script and outputting it as a CBOR from hex code, I guess. And there's the public key, so I guess that would be datum. And yeah, the public key hash is the datum. And we lock 1 million Lovelace or 1 ADA into the validator owned by the datum. So here the datum is the public key. So a public key that we have inserted. I guess it's, or maybe it's not a private key. Oh, I forgot the extension S key. No, it's the private key. Yeah, well, from private key. Uh, but the datum here would definitely be the public key. So you don't on-chain the private part of it. Um, we're doing the transaction yet, waiting for it with Lucid, then showing in the log when it's done, the text ID and the datum for that. Yeah, Lovelace. This is the actual transaction, creating a new transaction, pay to contract, the contract address, Lovelace's, and complete it. Signing it and returning the submitted signed TX. Then when we unlock, so let's see how it, same here, block process for the API, Lucid for a transaction. This is again reading the private key. I guess Lucid can convert between private and public. That's why it's just reading the private key, probably. We're checking the validator. And yeah, and then we're passing a redeemer when you unlock. And also adding a hello world. I guess it's actually in hex code, so in the example we used, we will have to convert it from hex to UTF-8 to actually see this hello world. And we're using the redeemer, sending again transaction. Collecting from the UTXO, because the datum is residing in the UTXO. Yeah, it's starting to become clearer again to me, like what the validator is, what the redeemer and the datum is, but it's going to be a long journey to remember all this and to really start to code. But I hope this is helpful for other new beginners, because I'm mostly a staking pool operator in my skill set, and I briefly did the tutorials back in the days on Plutus, but I never had the time to do the coding. There were so many other tasks at the time. So hope many can be with me, or some others can be with me on this journey to relearn everything, and hopefully it's helpful for others as well. Yeah, let's now we have seen the code. Let's revisit it and see also what they say here. So this is the validator, the one we saw here, right? It's parameterized by a verification key hash, the owner. This is the where we do that. And a message. Remember, say here that the datum is set when locking phones in the contract and can therefore be seen as a configuration. Here will indicate the owner of the contract and requires signature from them to unlock the phone. So this is why we are sending the public key when we are doing the datum, and then when you sign it to unlock the phones, you are using the signature, the private key part to sign. Yeah, very much like it already works on a typical non-script address. So you have a public key and a signing key to do the transactions. And they add the hello world because this is tradition with all hello world tutorial script is you have a hello world output. And they pass it as a UTF-8 encoded byte array to be passed as a redeemer when spending from the contract. Redeemer message, hello world. Yeah, and so the validator is the contract itself. We're building it. And it has a Plutus blueprint script. Let's see that. Describes version number, what type of script. That's actually important because there, for compatibility reasons, there's version 1 and version 2, and maybe in the future a version 3 of Plutus version. It's interesting they add a license to the smart contract, I guess. What is the description in the JSON for that validator? They have a title for the validator, a datum with the title of the datum, a schema for that's interesting. I'm not sure yet. This may be something you can investigate in another video. I need to relearn all of this. And a redeemer with a title redeemer. Compile code. So this is probably CBOR, I'm guessing. The hash. There's some definitions. Yeah. So this blueprint, what you see here, this describes your on-chain contract and its binary interface. Particularly generates the on-chain code that will be executed by the ledger and a hash of your validator that can use to construct addresses. Oh, cool. So this hash probably is the validator hash. This is the CBOR of the... Could it still be the CBOR of the contract? I'm not sure. Probably. And if you remember the tutorial, we actually interfaced with we first generated a private key and address using Lucid in its own script, generate credentials. So Lucid is a library used for transactions. We created a generate private key, and then we had the address from that private key. So you can generate the address, you can generate the public key as well from a private key. And then we went to the Cardano faucet and got that address and sent preview testnet data to it. So here we are creating the validator in a way that Lucid understands by reading the Plutus JSON. And I guess we're making it from CBOR to hex. To hex is what we're calling. And also, we're definitely converting it to hexadecimal text, but we're also looking at the CBOR to convert it to the hex. And the datum when we are locking in must match the one that was represented by the validator. So let's look at the blueprint again. I guess the datum here is the owner or the owner public key. And yeah, it's a constructor with a single field that's a byte array. So the datum is a type constructor, and has a title and a field that's a reference, that's a byte array. And the byte array will be a hash digit of our public key. So if we go back to the locking, yeah, so here we are getting the public key hash. And creating the datum as a constructor with the public key hash. And adding to that the one ADA, and then sending the transaction ID, the hash, and the data. Yeah, that's the ID, and that's the data. I guess this is the byte version of it, but probably if we converted it to hex, I wonder if it will be this one. Probably. We can even inspect the datum, as they say here. Not 100% sure of that, but maybe something for another video. And again, like when we send a datum into the text to have, and we lock the ADA, and then we unlock it with the redeemer. And the redeemer can often just be this signature, and in our case here with the hello world, we also pass the hello world UTF-8, basically a coding of letters, and convert it to hex, and that's also part of the transaction. So yeah. And yeah, UTXO and address, of course, they have index. So the first one created on address is 0, and so on and so on. And that's actually like quite important for like a ton of stuff. Like for example, some wallets have like edge cases where if you have like, let's say, millions of UTXO, they can have some trouble. Or whatever the limit is. But anyway, they can have some trouble when the UTXO set is really high. So you sometimes need to consolidate UTXO, so the address has less of them. But yeah, addresses can have many UTXOs, and they're indexed. Uh, so here, let's see, the constructor of the redeemer actually just passes this arbitrary data. So how are we actually unlocking it then? Don't we need also to pass the public key? Wait. Uh, no, this is just it's not doing the unlocking. Here's the unlocking part of it. All right. So we actually here we send the private key. So we are doing the signature as well. And using the redeemer, new transaction, getting from the contract this UTXO, using the signature from that with the address with the private key that we have here. Attach spending validator from. Let's think. Where we are signing it. But where are we actually passing the redeemer itself? From using from spending validator. Where are we actually saying what's the spending validator? Ah, promise spending validator. Maybe it's defined in the Pluto's blueprint. Let's see. Validators. Redeemer. Should be index 0 with a message using bytes array. Yeah, I'm actually not entirely sure like how does this actually create the spending validator. This part I need to investigate more. Uh, but at least I hope I have with my very newbie fumbling in this, like try to look at the difference between a redeemer, the validator, and the datum. And yeah, when you sign it, you pass both the signature and you pass the redeemer that can be some form of arbitrary data. Let's see. Let's maybe do one more read of this. This is from Jonathan Fishkoff, and he explained it from the course. Made a Medium article about it. Datum is the locker input. The redeemer is the unlocker's input. And the datum resides in a UTXO. And then when you redeem, you use the same UTXO as the input and pass in a redeemer explaining how they would like to be paid. And then the validator or the script uses the script context and make sure the input and outputs are consistent with what is requested. And if they are, it performs true and performs whatever it is, if it's a swap or something else, depending on how you decide the validator. And this is how it really works. In reality, the locker sends a datum hash when locking assets at a script address. So yeah, I guess even more specific, at a UTXO of a script address. And when you unlock, you must send the redeemer and the full data, such that it matches the hash that the locker used when locking assets. We will definitely look more of this in future episodes. And yeah, this is just my starting fumbling on this. Maybe we should start on the vesting contract, or maybe we should do that for another video and keep it short for this one. Yeah, I think we'll just do a short one for this one, and I will follow up maybe in a later video with trying the next contract as well. All right, thank you.